So the first time I did this page, I read this problem about crickets. This should say cricket, by the way. And I did it according to seconds instead of minutes. So I had to redo it. And then I redid it, and it wouldn't save. So it's like, today's a good day, everybody. It is. Every day is a good day, right, guys? It really is. All right, let's talk about, I wouldn't be a good teacher if I didn't show you how, like, we could actually use this. So we're going to talk about crickets because, you know, we all use crickets on a daily basis. So anything in real life that increases or decreases, like, at a constant rate, that would be a linear equation. So they have found that the number of times a cricket chirps in a minute depends on how warm it is outside. And we know this from summer. We hear more crickets than we do in winter. The number of chirps in 2 seconds is shown down here. So I see 0 chirps at 40 degrees and 8 chirps at 93 degrees. The problem is that's in 2 seconds, guys. So we have to multiply our number of chirps by 30 because there are 30 2-second intervals in an hour. Rewind that if you need to. So if there are 0 chirps in 2 seconds, or excuse me, if there is, 0 chirps in 2 seconds, so like 40 degrees, if there are 0 chirps in 2 seconds, there would be 0 chirps in 60 seconds too. Okay, so how many chirps? 0. All right, so 60 seconds is 1 minute. That's why right here, see how it says 1 minute? So 60 seconds. So 8 chirps, so let's think about this. 8 chirps in 2 seconds, multiply that by 30, that's gonna be 240 chirps in 60 seconds. So if it's 93 degrees, we're gonna hear 240 chirps in a minute. Okay, so we had to change those to chirps per minute. That was sneaky. And it said the number of times they chirp is dependent upon the temperature. That makes the temperature X and the chirps Y. So let's graph this. Since I've done this 3 times, I know what to count by. So we have been taught a long time ago that if you need to skip by some, you can use this break here. So I'm gonna let this first be 35, this one be 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. And if you're like, I don't know why you picked those, it's because those are my X values, 40 to 93. So 0 to 240, I'm going to start at 0 because I need 0. I'm going to count by, I'm going to count by 30s. I counted by 20s in my last video that got deleted, but save some time. 30, 60, 90, 120, 150, starting to stay in line, 180, 210, 240. And these are my chirps. Chirps. Did I spell that right? It's been a long day. This is my temperature outside. Okay. So my first point is 040. We can totally plot that. 40, 0. Did it right, Langeli. So over 40 up 0 is right there. I'm going to change colors because it's really blending in. How about this purpley color? Well, that's pretty. And then my other is 93 to 40. I know a lot of you don't know how to take me. You know, I'm weird. It's okay. I don't mind. 240, actually, okay, here we go. That's, oh guys, I have double vision. This is really hard for me. Okay, that's 90, so this would be 93. Okay, so 93, 240. Ready? Watch these mad graphing skills. Okay, I hope your line's better than mine. That was really pathetic, but if you think I'm changing it, you're wrong. Okay, I have an arrow going to the right because they could potentially increase, but they're not going to go into the negatives. So part A was do the graph, done. Part B, what's the equation? Oh, in standard form. That's mean. That's okay because we're smart. That's why it's okay. So we're going to do M equals, we're going to do the Y value. So I'll do 240 minus 0, 93 minus 40. Solve that. That's 240 on the top. That's 53 on the bottom. The calculator is the name of this app. It's a wonderful app for an iPad. Hopefully you can get it. I asked the tech department to download it for you. Okay, that's your slope right there. 4.5 is your slope. So now I'm going to do my point slope form, which is what I used on the first page. I'm going to do y minus, I'm going to pick this point because I like it more. Okay, so I'll do y minus 0 equals m. Oh, hold on, x minus 40. You might be like, Miss Langeli, I thought you said we couldn't use decimals. Hey, on word problems, have at it. You use all the decimals you want on word problems, okay? Well, y minus 0 is, well, I'm just going to ignore the 0. Distribute 4.5x. Distribute 4.5 times negative 40 or minus 40. There we go. That looks good. Negative 180. That is such a pretty equation. That's slope-intercept form. They want it in standard form. So this is slope intercept form, which is no good. Boo, boo, they went in standard form. So we are going to, that's right, I like my own commentaries. I have to keep myself entertained, kids. Okay. All right. So we need to get rid of the decimal. If you remember, I told you to multiply everything by 10. Boink, 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 multiply by 10. So after we multiply by 10, we're going to have 10y. Oh, that's quite the color. Equals 45x minus 1,800. Move the 45x over, like I taught you in the previous page. That's negative 45x plus 10y equals negative 1,800. Divide everything by -1. You can leave it like that. This is totally fine. This is standard form because we don't have any fractions, decimals, and everything's on the left. But just so you know, you might see the sign switched around. And to be honest with you, I don't care. As long as you know that they're both good. Now what we can do is take that equation based off those two itty-bitty points and predict something we don't know. So let's say it's 70 degrees outside and we're like, I wonder how many times a cricket's going to chirp, because I know that's what you guys did this summer. Actually, with COVID, that might have been what you did. So there's really nothing else to do except to count the crickets. So that would be y equals 4.5. I tell my own jokes, and just so you know, I laugh at myself. You plug 70 in for x because x was temperature. See how I took this x and I made it 70? And now we take our handy dandy calculator, and it's 135. So we say y equals 135, and this is how many times it would chirp in 1 minute at, that was cute, 70 degrees. All right, now this last one is just multiple choice, beautiful multiple choice problem. The manager of a small office is going to order 140 packs of printer paper. Based on the average daily use, she knows that the paper is going to be about 80 days. So knowing that, I know it's going to go down because we're going to use paper, and it's like how many packs of printing paper we have left. So which one of these represents like how much she has left? It would definitely be A, because it's going down and starting at 140. However, I'm going to be a bit of a turd, and I'm going to tell you that should have been a dot, not an arrowhead, because she bought 140 to start. The last thing we're going to very briefly talk about before the next video, which did not get deleted, P.S., which, yay, you win some, you lose some, are parallel versus perpendicular. Just FYI, parallel lines, they're never going to cross, guys. And the reason they're never going to cross is because they have the same slope, okay? And they have different y-intercepts. And if you're like, how do you know that? Because I know that, and that's what that says right there. Same slope, different y-intercepts. And if something's perpendicular, that means that their slopes are what we call opposite reciprocals, okay? Or negative reciprocals. I like the opposite reciprocals. So let me just give you a couple of examples real fast. Negative 2/3 and positive 3/2 are opposite reciprocals. Okay, and I don't even care about their y-intercepts. Their y-intercepts can be the same. I don't care. It's the slopes we worry about. So let's talk about, how about positive 1/4 and, okay, let's flip it upside down. So it'd be 4/1, or just 4, and make it negative. Okay, that's the end of this video.